In this video, we're going to look at transformations. We want to be able to describe the transformation of a function from the equation or the graph. We want to be able to rate the equation of the transformed function from the graph or a description. And we want to be able to graph a transformed function from an equation. This should build on most of what you did in Algebra 2, talking about shifts, stretch, shrinks, and reflections. So just some terminology. A transformation is just basically any mapping of the graph or equation that you start with to the new one. And they can include translations, which are shifts, scale changes, which are stretches or shrinks or compressions, and reflections, which are flipping. We will specifically only look at reflections over the x and y axis. A rigid transformation is where the original and the transformed equation are exactly the same size and shape, so they're congruent. And those would be translations, reflections, and any combination of those things. Non-rigid transformations are where the general shape of the graph will stay, but the size of the graph may be distorted. So it's a stretch or a shrink, or again, any combination of those two things. Translations occur when we add or subtract to the x and y values. A constant that is added to the x coordinate is going to be a horizontal shift. Right is going to be positive, left is going to be negative. When we add a constant to the y coordinate, that's going to be a vertical shift, so up or down. Up is positive, down is negative. When we talk about scale changes, which are our stretches and shrinks, again, any multiplication is going to be a scale change or possibly a reflection. So my scale change is always a positive number. So when we multiply the x coordinate by a positive constant, then that's going to be a horizontal scale change. It's a stretch if the absolute value of that number is greater than 1, and a shrink if the absolute value of that number is less than 1. When we multiply the y coordinate by a particular constant, then that's going to be a vertical scale change. Again, greater than 1 is a stretch and less than 1 is a shrink. When we multiply the x and or y coordinate by a negative, then that's where we get our reflections. So if we have a negative number, then the number represents the scale change and the negative sign represents the reflection. So when there's a negative on the x coordinate, that's going to be a horizontal flip or a reflection over the y-axis. If there's a negative on the y coordinate, then that's going to be a vertical flip or a reflection over the y-axis. So my general transformation rule is going to look like this. xy becomes a times the quantity x minus h, and b times the quantity y minus k. So again, the absolute value of a is my horizontal stretch and shrink. If a is also negative, then that's a reflection over the y-axis. B is going to be your vertical stretch or shrink. If b is negative, then reflection over the x-axis, or you can think of that as a vertical flip. H is going to be your left to right shift, and k is going to be your up and down shift. So some examples of just looking at some transformation rules. If we have xy equals x minus 10, y plus 8, then that's a shift of 10 units left and 8 units up. Remember, anything on x is a horizontal change, anything on y is a vertical change. So when we have x plus 4, y plus 3 in number 2, that's going to be a shift of 4 units right and 3 units up. In 3, we have negative 3x and then 1/2 y. So this is a horizontal stretch by a factor of 3. So horizontal because it's on the x. The absolute value is greater than 1, so that's a stretch. And then my scale change factor is always the positive value. We have a vertical shrink by a factor of 1/2. Again, vertical because it's on the y, and shrink because it's less than 1. And then the negative that is on the negative 3x is going to be a horizontal flip, or that would be a reflection over the y-axis. So in number 4, we have 4x and then 3/2 y. So this is a horizontal stretch by a factor of 4 and a vertical stretch by a factor of 3/2. Looking at number 5, what I want you to pay attention to is that this term right here is in factored form, and that's what we need before we can start talking about the transformations. So we want the x or y in the innermost parenthesis to not have a coefficient in front of it. So in this case now we're going to talk about this is a horizontal stretch by a factor of 2, a reflection over the y-axis, a vertical stretch by a factor of 3, and a shift of 1 unit to the right. In this last one, we are not in factored form, so we have to rewrite into factored form. So we're going to factor out the 4. So if I factor out the 4, that's going to leave me with x minus 5/4. And on the second term, we have to factor out the negative. So if we factor out the negative, then we have a y plus 7. So it's important to do those factorings so that you can get the appropriate shifts. Everything else will kind of be the same, but your shifts will be wrong. So this is going to give us a horizontal stretch by a factor of 4. Remember, we're looking at the factored form now, so we're looking at this form here. Reflection over the x-axis is from this negative right here. We have a shift to the left of 5/4 and a shift up by 7 units. So just kind of working backwards now from the words to the transformation rule. So if we're shifting 4 units to the right, so that's x plus 4, and 6 units down, so y minus 6. Here we have a shift of 9 units up reflected over the y or the x-axis, and a vertical shift by 1/2. So we have no horizontal changes here, so the x just stays x. And then here we have a shift 9 units up, so y plus 9. The reflection over the x-axis puts the negative in front of the y, and then the vertical shrink by 1/2, so we're going to put that scale change factor there as well. In number 9, we have a shift of 1 unit to the left, horizontal stretch by factor 7, reflection over the y-axis, and then shifted down 8 units. So the shift of 1 unit left, that's going to be a horizontal change, so x minus 1, horizontal stretch by factor of 7, so we're going to put the multiplier there of the 7, and reflection over the y-axis, which is a horizontal flip. So the negative is going to go on that x coordinate term, and then we're shifted 8 units down, so y minus 8. So in 10, we have a reflection over the y-axis, so that's going to put the negative on the x term. Vertical stretch by a factor of 3, so this is vertical, so that's why the 3 is on the y, and then stretch horizontally by a factor of 7. So make sure you pay attention to the words and not the order, because sometimes they'll kind of switch the order around on you just to try to trick you up. And then this last one, we have a horizontal shrink by a factor of 1/3, so the 1/3 is going on the x. Vertical stretch by a factor of 4, so the 4 is with the y, and then reflection over the x-axis, so that's going to be a negative on the y. So remember, reflection over the x-axis of vertical flip, so the negative is going on the y-coordinate. Once we take this and we start looking at it in the transformation equation, so if we've taken a basic function or any type of equation and then we have performed the transformation to that, so we're going to have it in the actual equation and not just the mapping rule. So in all of these equations here, we have this h value, and the h value is going to represent my horizontal shift or my left-right shift. So this is my horizontal shift. What I want you to pay attention to here is that in both of these equations, it's x minus h, but we say the horizontal shift is just h. So here we always want to change the sign on that horizontal scale or the horizontal shift number when we remove it from the equation. Then we have this vertical shift number, which is the k. So k is my vertical shift. So this is going to be my up or down shift. Notice here it's plus k in both of my equations, and we just use the number k. So we don't change the sign for the vertical change. The next thing that we're going to look at here is this 1 over a. So this is telling me what my horizontal scale change is. This is actually the absolute value of a. So first of all, my scale changes are always positive, so we have to take the absolute value. And here we have to take the reciprocal of the horizontal scale change number that's in the equation. So the absolute value of a is my horizontal scale change. So this is my stretch or shrink number. And then here, if a is actually negative, then that's going to indicate that we have a reflection over the y-axis. So again, this would be a horizontal flip, flipping left to right. So that's going to be crossing the y-axis. And finally, we have this b number here. So this is just being multiplied to the entire function. So this is my vertical scale change. Again, it's absolute value. We don't take the reciprocal here. We do the inverse operation on the horizontal changes, but not on the vertical changes. So this is my vertical scale change. And again, if b is negative in the equation, then that would indicate to us that we have a reflection over the x-axis. If we take a look here at moving from a transformation equation to the actual description of the transformation. So describe how the graph is transformed. You want to use your transformation words: shift, left, right, up, down, stretch, shrink, horizontally, vertically, reflections, things like that. One thing that helps some people is to write the mapping rule. So here, when we have y equals x minus 4, remember that is going to change. That's the inverse operation, so that becomes x plus 4. And then the minus 2 is your vertical change, so just y minus 2. Once you have this, then it's a little bit easier for some people to go into the words. So this tells me that I'm shifting 4 units to the right and 2 units down. If you can go straight from the equation to the words, that's fine. I don't necessarily need to see that mapping rule. It just is helpful for some people. On this second one, we have y equals negative 1/2 and then 4x inside the absolute value. So again, if you would like to write the mapping rule, remember inside the absolute value, that's my horizontal change. So we do the reciprocal here because we always do the inverse operation. So this is 1/4 x and then the negative 1/2 y. So that's where we get the horizontal shrink by a factor of 1/4, vertical shrink by a factor of 1/2, and that reflection over the x-axis. On this last one here, if we want to take a look at the mapping rule, inside the parentheses is my basic function. So the only thing that's happening horizontally is that we have x minus 2, and we're going to do the inverse operation, change that, so that becomes x plus 2. And then we are going to multiply y by 3 and add 5. So we have a vertical stretch by a factor of 3. We're shifting 2 units to the right and 5 units up. Next, we want to be able to look at a graph and come up with the equation for that graph without using your calculator. So the first thing I want to do is I want to look at this graph and I want to determine what is the basic function we're dealing with here. In this case, I'm dealing with the absolute value, so y equals absolute value of x. If it helps you to think about what that basic function looks like, go ahead and sketch it in there. Then what we can notice here is that the function that we have is just a shift of this basic function, moving 6 units to the right and then 1 unit up. So again, if it helps you, you can write that mapping rule. So 6 units to the right, 1 unit up. And then from there, we're going to write the equation of the function. So remember, inside the absolute value is going to go my horizontal change, and we do the inverse operation. So it's x minus 6 inside the absolute value bars, and then the plus 1 is my vertical change, and that's just going to go outside the absolute value. Over here on the second one, this is a square root function, so we're starting with y equals the square root of x, which remember normally goes through 0, 0, 1, 1, and 4, 2. So my graph would look something like this. Notice here that it's telling you the 0.11 has been scaled. So this is telling us that we have a scale change. It's difficult to recognize a scale change just from the graph. So typically when you have a scale change, they're going to give you this information. So the 0.11 has been scaled to the 0.23. So what we can think about is to get from 1 to 2, we multiplied by 2. So my x-coordinate was multiplied by 2, and to get from 1 to 3, we multiplied by 3. So my y-coordinate was multiplied by 3. And then again, I can go to my equation, which is going to be y equals square root. Under the square root is my horizontal change, and that is the reciprocal. So this is going to be 1/2 of x. And then my vertical change is outside the square root, so we're just going to put the 3 in front. Finally, the last one, we can see that this is a parabola, so we know that we're starting with y equals x squared. This tells us the graph contains only a translation and a reflection, so there's no scale changes involved here. So if we can remember that normally my parabola would look like this. So it's been flipped over the x-axis, so we have a vertical flip. And also my vertex has been moved to the right and up. So if we think about our transformation rule, if that helps you, I have been moved 2 units to the right, so x plus 2. We have done a vertical flip, so flipped over the x-axis, so we've got a negative on the y, and then we would do the shift up, so then we've got the plus 4. We're going to go y equals And then remember inverse operation for the horizontal change, so x minus 2 quantity squared. We have a negative out in front because of the reflection, and then after that we've shifted up 4 units. Here we want to be able to write the equation when we're given the description in words. So we're starting with y equals 1 over x. It's been shifted 3 units to the left and 5 units up. So again, if it helps you to write that mapping rule, go ahead and do it. If you can get there without doing it, that's perfectly fine as well. So we're starting with this equation, y equals 1 over x. So we have 1 over, and then my horizontal change is going to go underneath that fraction. So in the denominator, we're going to do x plus 3, because remember, inverse operation on any horizontal. And then we're going to shift this whole graph up 5. So we're just going to add the plus 5 to the end of that function. On 19, we're starting with e to the x, and it has been stretched horizontally by a factor of 5. So that's going to be 5x. Shrunk vertically by a factor of 1/4, so 1/4 y, and reflected over the y-axis, so that negative is going to go on the x-coordinate. So here I'm going to start with y equals e, and then in place of my x, I'm going to do my horizontal change, so this is going to be negative 1/5 x. So remember, we have to take the reciprocal for that, and then in front, I'm just going to put the vertical stretch, or shrink in this case, which is 1/4. Finally, we have this last one. We're starting with y equals x cubed, and we're going to undergo the following transformations in order. So we're just going to kind of start working through this one. So y equals, I have a horizontal shift of 4 units to the left, so we're going to replace that with x plus 4, and then keep the cubic function, which is my basic function. We have a reflection over the x-axis. So if I'm reflecting over the x-axis, that's a vertical flip, so we're going to have y equals negative x plus 4 cubed. Since that's a vertical flip, the negative is going to be outside the basic function. Next, we have a vertical stretch by a factor of 3. So again, since that's vertical, it's going to be outside the basic function, so outside the parentheses, so negative 3 x plus 4 quantity cubed. And then finally, we've got a shift of 2 units down, so we're just going to subtract 2 to the end of it. Okay, and then the final thing that we want to be able to do is to sketch a graph of a transformed equation, again, without your calculator. So the first thing that I want to think about is my basic function, y equals x squared. So you should be able to sketch that basic graph. So you know it goes through 1, 1, 2, 4, 3, 9, negative 1, negative 1, negative 2, 4, negative 3, 9. So we've got our basic graph there. You don't necessarily have to draw the basic function, but I think for a lot of people it helps. Also, some people like to kind of just jot down the t-chart. So we had the point 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. So it just kind of gives you a little bit of frame of reference. Then we're going to think about what's happening to this graph. So this x minus 5 quantity squared, this is my horizontal change, so that's really going to become x plus 5. And then the plus 3 outside is my vertical shift, so that's going to be y plus 3. This tells me what I need to do to each of my x and y coordinates. So to each of my x coordinates, I'm going to add 5. Then my y coordinates, I'm going to add 3. So this is going to give me 5, 3. When I take the 1, 1 point, that's going to give me 6, 4. When I take the negative 1, 1 point, that's going to give me 4, 4. When I take the 2, 4 point, that's going to give me 7, 7. And when I take the negative 2, 4 point, that's going to give me 3, 7. So now I can plot these new points. So I'm going to go 5, 3, 6, 4, 7, 7, skip the 4, 4, and 3, 7. And then I've got my new graph here. Now some people can work a little more visually. Once you have the original basic function graphed here, they can just kind of move the points over and up, and that is perfectly fine. Just trying to give you some different strategies that you can use. Here's a second example. This one involves a scale change. I think when you're dealing with the scale change, it does make it easier if you use the t-chart. So this is the basic function of absolute value of x. So just plotting a couple points here. And again, I'm going to jot down a couple points from my t-chart so I know 0, 0 is in there, 1, 1, negative 1, 1, 2, 2, negative 2, 2. And again, I'm going to think about what this transformation means. So inside my basic function, inside the absolute value, I have 1/2 x. Remember, we have to take the reciprocal here. So this is 2x. So it's technically a horizontal stretch by a factor of 2. And then the negative is a reflection over the x-axis, which is a vertical flip, so a negative on the y. So again, this tells me what to do with my points. So I'm going to multiply all my x values by 0, or by 2, which is still going to give me 0 here, and then change the sign on the value, but again, that's just going to give me 0. So with the 0.11, I'm going to get 2, -1, and then I'm going to get -2, -1. 2 times 2 is going to give me 4, -2, and then -2 times 2 is going to give me -4, and then again -2. So if I plot my points now, I have 0, 0, we have 2, -1, -2, -1, 4, -2, and -4, -2. So then I can kind of draw my graph based on those points, and then we can see the horizontal stretch by a factor of 2 and the reflection. So the last one is a combination of a couple of different transformations here. So again, let's start with my basic function is the square root of x, and I know that's 0, 0, 1, 1, 4, 2, 9, 3. Then I'm going to think about my transformations. Under the square root are my horizontal transformations, which is x minus 1. We're going to change that to x plus 1, so we have to do the inverse operation. And then outside that, we have -2y and then -3. So this will tell me what to do with my coordinates to get my new coordinates. So I'm going to add 1 to my x coordinates. So this is going to be 1, and then multiply my y value by -2 and then subtract 3. So that's going to give me -3. Here I'm going to do 1 plus 1 is 2, and then this is going to give me -2 minus 3, which is -5. And then this 4, 2 point is going to give me 4 plus 1 is 5. And then 2 times -2 is going to give me -4 minus 3 is -7. And then 9 plus 1 is 10. And then we've got 3 times -2, which is -6, minus 3, which is -9. So now I can plot my new points. So I have the point 1, -3, 2, -5, 5, -7, and 10, -9. Draw my graph in here. And then we've got our graph, which has been shifted to the right, vertical stretch, vertical flip, and then shift 3 units down.